Okay, we've done all this. We did miss one of them on the multiply 3 and 4 by 1 digit. But we're going to go ahead and move on to multiplying using partial products. Okay, partial products. Just another way to look at the same thing we've been doing, right? Same process, same conclusion, just a different way of looking at it for folks who might, need something a little bit different. Think about this. If I see 391 times 7, let's think about how I would do that as somebody who grew up in the 90s and was taught how to multiply in the 90s. I would start by doing 1 times 7, which is 7. And then I would do 7 times 9, which is 63, right? I would put the ones part of that down here. So that's 3. And I would put the 6 up here. So that's 63. And then I would do 7 times 3 is 21, plus 6 is 27. So the answer would be 2737, 2,737. That was the way that I learned it. That is an absolutely valid way of going about it. But let's look at that a little bit more closely, because I want to take a look at what the Khan Academy is asking us to do, and I want you to see that the steps are really the same. It's all about how do we organize it and how do we visualize it, right? The first thing that it says here is 7 times 1. Well, that's the first thing we did as well. So again, same process, just a little bit different way of organizing it. Second, well, what it does here is, let's see, 90. So we get 7 times how many tens? Well, that's 9 tens, right? That's what we do. That's what we did on this one. We took our 7 and we multiplied it. That's not what I meant to do. We took our 7 and we multiplied it by the 9 tens to get our next digit, which got us 63. We happened to put the 6 up here and the 3 down here, but that's where that 63 came from. And then 2100 is 7 times 300s. And then you could add this up. And it gets us a different answer than I got. Did I mix something up? 7 times 9 is definitely 63. 70. So this gets 2170. Oh, 630. Yes, you're right, because that is 9 tens. Thank you. 1 silver key. Well done. I don't have the applause button on this particular part, but yes, excellent point. If you were one of my students, that would be extra credit. Legitimately, when I make a mistake on the board and a student asks me about it, I always try to give them extra credit if I can, because that's very important. You're right, it is 630 and not 63, which does mean I did indeed get the right answer with 2,737. Lovely. So with that in mind, we're going to go ahead and take a look at this problem that says Joe tried to evaluate 612 times 8 using partial products. His work is shown below. Step 1, 16 is 8 times 2 ones. That makes sense to me. Step 2, 80 is 8 times 110. That also makes sense to me. Let me go ahead and zoom in on this a little bit. And then 8 times 6 tens? No, that should be 8 times 6 hundreds. This person is making a very similar mistake to what I made. I made them into ones instead of tens, which is why I got 63 instead of 630. Whereas in this case, instead of 600s, it should be instead of 610s, it should be 600s. So Joe's mistake is in step 3. I hope this process makes sense. It's the same kind of taking apart and putting together that we've been doing in this particular stream from the beginning. It's, like I said, just a bunch of different ways of looking at it to try to see what works best for each individual student. All right, so let's see what happens here. We don't have to do much here because most of it's already done for us. So it's 5 10s and 5 1s, right? 4 thousands, 900s, 5 10s, and 5 1s. So 5 10s is 50, times 2 is 100. So now we just have to add it up. 8,000, 9,800, 9,900, 9,910. I'm going to double check and make sure I counted that properly, because you never know. 98, 99, 99, 10. Yes. Excellent. Aaron tried to evaluate 48 times 2 using partial products. Her work is shown below. Okay. So step 1, she did 2 times 4 10s. All right, well, that would be 80. And then she did 2 times 8 1s and got 16. So when she added those together, she got 96. Now, if I was giving this problem to a group of students, I would stall. I would give them a chance to take a look. Tigress Lily, really glad that you're here. Don't you worry, the VODs are on youtube.com. Actually, no, this one's at professor-cunningham.com. But yes, I started at kindergarten, so don't you worry. No matter how much you need to brush up on, I will help you out. I think that Aaron is correct here, but I think that some students might think that Aaron is wrong because of the order that they went about things, right? Because when we do this, when me as an adult who learned in the 90s does 48 times 2, I start with 2 times 8 is 16, which is where the 6 goes there and the 1 goes in there because it's a 10, right? That's how I would start. So I could definitely see a student going, well, wait a second, Aaron did 2 times 4 10s first and then 2 times 8 1s second. And this is a great place to talk about how certain operations can be done forward and backwards without a problem. Like this one. 96, I believe, is correct. Absolutely correct. Well done, us. And that's multiplying using partial products. I hope that makes sense. Again, it's just another way of breaking these down. And the thing about this particular topic that makes it so important is later on when we start talking about algebra and we start talking about dealing with variables and multiplying them around, a lot of the patterns that we're going to use there are going to be very, very similar to the patterns that we're using here. So it's not going to be as much of a leap, hopefully, as it was, for example, for me. I did not have a good pre-algebra.